Welcome back. This is the video 2 on data structure. We will see here how a linked list looks like. That is, the nodes are linked through addresses and how a new node gets inserted into an existing linked list. Let's recap our previous lesson. The rate file, which we assumed a song file, is being written in vacant spaces and gets fragmented. Here we see how the fragments are linked sequentially so that the media player can continue playing the song from the starting bit to the end. Now, a little shift to the idea. The media player is a program file and a song is a data file on which it does some processing, right? Both of these are stored permanently on the hard disk. And for a program to be executed and the data to be processed, both of these must be loaded to memory. The media player is loaded to memory as well as the song file. Now, one thing to be noticed here is that the song file on which the media player will do some processing does not necessarily mean to be located adjacent to this media player's location. So it may find any vacant space over the memory. So the media player is linked to the starting address of the song file so that it can start playing. Similarly, the Microsoft Word program file and the docx data file have been loaded onto memory and linked. Please note that hereafter we will refer to memory only when dealing with data structure implementations, okay? So there will be no hard disk concept because the algorithms of the data structure are implemented considering the RAM. Now suppose we have records of 4 students like this. And these records have been written in a scattered way in memory. That means they are not adjacent to each other. Now let's see how a linked list will look like when these records will be stored in it. We call this box-like structure as node. And it has two parts: data and address. Each node will store one record. So we will have 4 nodes like this. Now let us store the records in the data parts. Imagine that the addresses of these nodes are 743 like this, then 291 here, and here is the address, 521 here, and 478 here. Okay? We would like to link the first node with the second node. So we put 291 over here because the 291 is the address of the second node. So when we put 291 in the address part of the first node, this first node gets linked to the second node like this. Similarly, we put the address of 521 over here so that the second node gets linked to the third node like this. And the same way, 478 will be placed here and the third node gets linked to the fourth node like this. Now the question is, after this node, this fourth node here, the data is over now. What will happen to the address part of this last node? Since there is no node hereafter, we put a null pointer that does not point to any address. Now, this is just a decoration, just like our electrical friends do to indicate grounding the wire. It has nothing to do with the grounding thing in data structure, right? Okay, this is just a decoration. Now we have a new record here, and we want to insert this new record as a fifth node in this existing list. So there are three steps. First, create a node. You notice the address here, 114. It has been a randomly selected vacant location. Then you load the data and set the address part to null. Now our new node is ready to be inserted into this list. So we are going to insert the new node in this list. This is the third step. Okay. Now you see here, if you put this 114, the address of the new node here, then this node will be linked to this new node, right? So it will be something like this. So the new node is now a part of the linked list. This linked list is of internal storage type. Since the data itself is located within the node, in every node you see here, the data is stored inside the data part. Now there is another type called external storage. Let's have the song file example again. Let me blank the upper part. It will be easier for you to concentrate. That is nice now. You see, three songs are loaded at different locations. One at 119, one at 205, and one at 611. Now you assume that you selected these three songs at a time with the help of your mouse, and right click on that and open with media player. Now what the media player will do? The media player will play the songs one by one, right? Now how the media player is doing this operation, that playing the song, then when the song file is over, then it automatically jumps to the second song and starts playing, and when the song 2 is over, then automatically jumps to song 3 and starts playing. Actually, it creates a linked list with the starting addresses of these songs like this. See, the first node is at 104, the second node is at 977, and the third node is at 582. Now you see that in the first node, it has stored the starting address of song 1. Similarly, in the second node, it has stored the starting address of song 2. And in the third node, it has stored the starting address of song 3. Now, in the address part of the first node, you put the address of the second node like this. So visually, you can see here, the 977 has been written here, and conceptually it is shown here that 977 is written. So as soon as you put 977 over here, you get a link between this first node and the second node. So here you also see that the first node here is linked to the second node. Similarly, if you put 582, the address of the third node, over here, then you get a link between the second node and the third node like this. And of course, the null pointer is at the end of the third node. Now you can see that the first node is carrying the 119, the address of the song 1. So whenever the song 1 is over, then automatically following the address 977, it jumps to the second node. And in the second node, there is the address of the second song, 205. So it starts playing. So in this way, the media player actually creates a linked list of your selected songs. Now, I hope it's clear how nodes are linked through addresses, and also a new node is inserted into a linked list. In the next video, we will talk about how nodes are linked through pointers, right? Take care.